So we are starting with exercise 2B of relations and functions. Okay, let us understand the first problem given over there. Okay, one diagram is given to you. They have given something like this: P, Q, R, and S. Okay, and the second set is 1, 3, 5, 7, 9. Okay, and the mappings are given. So P is mapped to 3. I'll draw this for you. R is to S. R is to 5, sorry, and then Q is to 5 and S is to 7. S is mapped to 7. Okay. So now they are asking you domain, codomain, and range for this. So domain is nothing but all objects that are related from the first set. Okay. So each and every object is mapped. Okay. From P, one arrow is coming out. From Q, one arrow is coming out. R and S arrows are coming out. So the domain is PQRS. So all objects from the first set which are mapped, okay, or which are related. Range. Range is all objects in the first set, or all objects in the second set, those are related. Okay. So if you see 1 and 9, they are not related with each other, with any other element. They are not related with any other element from the first set. Okay, only 3, 5, 7 are mapped with some other element in the first set. So 3, 5, 7 are a part of range. And codomain. Codomain is the entire second set, whether any object is mapped or not, but then it is the entire second set. So that is the solution for the first problem. Okay, fine. Now let us go to the second problem. Second question. The figure shows the relation between sets P and Q. Write the relation in set builder form and in the roster form. Okay, and what is the domain and range? So see, first set, second set, 5, 6, and 7. 5 is mapped to 25. 6 is mapped to 36. 7 is mapped to 49. Okay. Now in set A, the first set, the objects are X. In set B, the objects are Y. Fine. So set builder form. Set builder form is nothing but the descriptive manner. So the relation R1, you can write relation as R1, R2, X1, X2, anything you want to write, you can write. It has ordered pairs X comma Y such that, okay. Now see, 5 has a relation with 25, 6 has a relation with 36, 7 has a relation with 49. Okay. So if this is X and this is Y, so don't you feel Y is equal to X square? Okay. 5 square is equal to 25. Okay. So how X and Y are related? We'll write Y is equal to X square. Whatever value of X we put, it will be squared. And it is true for all the three cases. So, but then this is only specific for 5, 6, and 7. So X belongs to 5, 6, 7. That also we need to specify. It is not true for all real values or all integer values. It is only true for 5, 6, and 7. Okay. So this is how we present. So this is the set builder form. Roster form. Okay. 5 comma 25. This is the objective manner. 5 comma 25. 6 comma 36, 7 comma 49. Okay, 5 is mapped to 25, 6 is mapped to 36, 7 is mapped to 49. Okay, domain and range I will verbally discuss with you all. Okay, so now the domain is 567 and the range is 25, 36 and 49. Fine. Let us proceed with the next problem. Question number 3. Now in question number 3, they have given the relation from B to A that we need to identify. So first they have given A and B. Okay, but then I'll write B first because the relation is from B to A. Okay. If you refer the problem, they have given set A and set B, but then I'm writing B first and set A. Okay, set A is A, B, C, D. Right? Okay. Now see, what is a relation? Relation is a non-empty subset from a particular set to the other set. Okay, non-empty subset of a Cartesian product also you can say. Okay, so this relation, the relation which is to be established from B to A. Okay, so our relation will be a subset of B cross A. Fine. Now the first one, Z comma X, Z comma Y, X comma A. Okay, ZX, ZY, XA. So ZX. So this particular ordered pair is from B to B. It's not from B to A. It's from B to B. Okay. So obviously we need not check the other ordered pairs. So this is not a relation from B to A. Fine. Okay. Then let us take the second example. The first one is not a relation from B to A. Second one, Z comma A, Z comma C, Z comma D. Okay. ZA, ZB. Acha, I forgot ZB. That also I'm writing. Okay. Now ZA, ZB, ZC, ZC, ZD. Okay. Now these ordered pairs are framed in such a way that the relation is from B to A. The first component is from set B. The second component is from set A. Okay. So definitely this is a relation from B to A. Right? Okay. Next one. Let me just erase this. Fourth, B comma Y, C comma Z, A comma X. Okay. Now if you take a look at the ordered pairs, it is B comma Y. Look at the first ordered pair. So this relation, this ordered pair is suitable for a relation which is from A to B. The first component is from set A, but then that should not be the case. The first component should be from set B, right? So this is not a relation from B to A. Okay. And the fifth one, XD, YC, and ZB. So look at the ordered pairs. First component, okay, they are from set A, set B, sorry, and second components are from set A. So that's completely fine. So it's a relation from B to A. Okay. It need not have the entire B cross A. Remember this. The relation need not have the entire Cartesian product. It's a subset. It can be entirely or not entirely. Right? Okay. And the third one. I forgot the third one that I will solve right now. Third sub question. Okay. XB YA. Now the first components. The first components are from set B. That's perfectly fine. The second components are from set A. That is also fine. So it's a relation from B to A. Not a problem. Okay. So the third one, yes, it's a relation from B to A. Let us start with the next problem, question number 4. Okay. Just take some time to read the problem. Yeah. In each of the following, state which of the ordered pairs belong to the given relation. Now the first one, x comma y. It's an ordered pair such that x is greater than y plus 5. Okay. So that's the relation which is given to you. Now the first ordered pair, 1 comma 0. So 1 comma 0. Okay. This is x and this is y. Okay. X should be greater than y plus 5. This condition should be true. So 1 is greater than 0 plus 5. 1 is greater than 5, which is false. Okay. So 1 comma 0 is not a part of the ordered pairs. 1 comma 0 is not a part of the ordered pairs. Okay. So we'll test for the second one. The second one is 8 comma 2. Okay. 8 comma 2. Let me just erase this. So this is x and this is y. X is greater than y plus 5. 8 is greater than 2 plus 5. 8 is greater than 7. So this is certainly true. Yes. So 8 comma 7, yes, it is a part of the ordered pair. Third one, third example, which third ordered pair which they have given. Third ordered pair is 0 comma 1. This is x, this is y. X is greater than y plus 5. So 0 is greater than 1 plus 5. 0 is greater than 6, which is false. So I cannot include this ordered pair in the final answer. Okay. The fourth one, 2 comma 8. Okay. 2 comma 8. So this is x, this is y. X is greater than y plus 5. So 2 is greater than 8 plus 5. 2 is greater than 13, which is false. I cannot include this in our ordered pairs. Then 9 comma 3. This is x, this is y. X is greater than y plus 5. 9 is greater than 3 plus 5. 9 is greater than 8. Yes, now this is true. Okay. So 9 comma 3 is a part of our ordered pairs. Okay. Now 10 comma 7, 123 comma 4 that you can check on your own. So two more ordered pairs are there. You can check it on your own. Okay, that I give you as self-study and you can present the final answer. Okay. Let us go to the next problem. Next sub question, I mean, second, x comma y is an ordered pair such that x into y is equal to 12. Now this is very easy. Okay, I'll just list down all the ordered pairs. 12 comma 0, 0 comma 12, 12 comma 1, 6 2, and 7 5. Okay, so 3 into 4 is 12, 4 into 3 is 12, 12 into 1 is 12, and 6 into 2 is 12. So these are the ordered pairs. Okay, you cannot include the ones which I have crossed. The ticked ones are the required answers. Okay, let us go to the third sub question. Fine. So the ordered pairs have x comma y such that y is equal to x plus 3 upon x minus 1 and x is not equal to 1. Okay, so the first ordered pair 0 comma 1. So this is x and this is y. The condition is equal to y is equal to x plus 3 upon x minus 1. So put the value of x as 0 and y is 1. So 0 plus 3 upon 0 minus 1. So 1 is equal to minus 3. So this is false, right? 1 and minus 3 are not equal. Okay, so 0 comma 1 is not the part of our required ordered pairs. Fine. Next one. 2 comma 5. This is x and this is y. Y is equal to x plus 3, x minus 1. So y is 5, x is 2. So this is equal to, yes, it's 5 is equal to 5. The LHS and RHS are same. That means this is true. So we got our first ordered pair from the list which they have given. 2 comma 5. Okay. Now the next one. Next ordered pair which they have given is 5 comma 2. So this is x and this is y. Y is equal to x plus 3 upon x minus 1. Okay. 2 is equal to 5 plus 3 upon 5 minus 1. So this is 8 upon 4, which is 2. Yes, so this is also true. So 5 comma 2 is also a part of our ordered pairs. Okay. Now 3 comma 3, 7 comma 5, and 7 comma 5 by 3. Okay. These three ordered pairs, you can do it as self-study and include only those ordered pairs in our final answer which gives you a true answer. Fine. Okay. So let us proceed with the next problem, that is question number 5. Question number 5. Sub question A. Just a second. Yeah. So n is a set of natural numbers. Describe the following relation in words. Okay. So A. And also write their domain and range. See, domain and range I won't discuss because domain is the, of course you have to write it down in the paper, but then domain is a set of all first components, range is a set of all second components. So that's very easy. But then we will just try and understand how to present this. 18 comma 9. And the last one is 20 comma 10. Okay. So describe the following in words. So this is roster form which is given to us. The same relation I'll just write it in set builder form. Descriptive manner. So these are ordered pairs x comma y. So if this is X and this is Y, so everywhere, if I if I consider X, the value of X is exactly 2 times the value of Y. So X is equal to 2Y, and Y belongs to 1, 2, 5, 9, 10. Okay, Y belongs to 1, 2, 5, 9, 10. Okay, then domain and range you can write it on your own, but then this is the descriptive manner. Okay, B 3 comma 1, 6 comma 2, and 15 comma 5. So this is X and this is Y. So let's describe it using descriptive manner, that is set builder form. So if you take a look at X, it is exactly 3 times the value of Y everywhere in each and every ordered pair. So X is equal to 3Y, and Y belongs to only 3 values, 1, 2, and 5. Okay. 1, 2, and 5. Okay. So that's how we need to present. Let's go to the C part of the problem. 1, 4, 5, 16, 7, 22, and 11, 12, 37. Now this is difficult for us to identify. Okay. So look at the ordered pairs X comma Y such that this is X, this is Y, this is X, this is Y. So your observation will play a very important role. The second value, that is Y, it is 3 times the first value plus 1. So Y is equal to 3X plus 1. See, 3 into 1 plus 1 will give you 4. That is for the first ordered pair. 3 into 5. 3 into 5 plus 1 will give you 16. That is for the second ordered pair. Okay. Then 3 into 7 plus 1 will give you 21, 22, sorry. And 3 into 12 plus 1 will give you 37. So X and Y are related in this manner. Okay. So now Y is dependent on the value of X. So X belongs to 1, 5, 7, 12. Okay. This is how we need to present. This is question number C. Let us go to example 6. Example 6 says Z is a set of integers. Describe the following relation in set builder form given the domain and range. So domain and range, domain is a set of all first components, range is a set of all second components that you all know. So they have given this 0 comma minus 7, okay, 4 comma minus 3, then 2 comma minus 5, okay, and then minus 13 comma minus 20, and then it's an infinite relation, okay, because they have mentioned dot dot dot. Now we need to establish a relation between the first component and second component. Okay, so how are the two things related for each and every ordered pair? Okay, so that we need to find out. So X is 0, Y is minus 7 in the first ordered pair, X is 4, and Y is minus 3 in the second ordered pair, so on and so forth. Okay, now we'll try to find out the difference between X and Y. In the first ordered pair, the difference between 0 and minus 7. So 0 minus minus 7 is 7. The difference between the second ordered pairs, between the first and second components of the second ordered pair. So if you see, now look at the third order pair, the difference is 7. Fourth order pair, the difference is 7. So difference is 7 throughout. Okay. So R is a relation which has x comma y, x minus y is equal to 7. Okay, now these are only some specific values. It's an infinite set. So we'll stop over here. We cannot write x belongs to something or y belongs to something. Okay. Yeah. So that was the sixth question. Seventh question. Write the domain and range of the following relation. So the relation is given to us. I'll just write that particular problem for you. X comma y such that x is equal to 3y and x and y are natural numbers less than 10. X, y, natural numbers less than 10. Okay. So now x is dependent on y. X is equal to 3y. Okay. So values of x are dependent on values of y. So I'll take y as 1, 2, 3, 4, 5, 6, 7, 8, 9. Natural numbers less than 10. Okay. So the first value of x is equal to 3 into y. The first value of y is 1. So x is equal to 3. Okay. So 1 will be mapped to 3. Then the second value of y is 2. So answer is 6. So 2 will be mapped to 6. The third value of y is 3. So 3 will be mapped to 9. The answer is 9. The fourth value of y is 4. Okay. Now see, when it becomes 4, the answer is 12, which is greater than 10. X and y are natural numbers less than 10. Okay. So 4 onwards, we cannot proceed because 3 into 4 is 12, 3 into 5 is 15, 3 into 6 is 18. So 4 onwards, whatever value we put of y is greater than 3, the x value will be more than 10. So only 3 ordered pairs are possible over here. The ordered pairs are 1, 3, 2, 6, 3, 9. The domain is first component 1, 2, and 3. Okay, I think I have written in the wrong way. Sorry. X value should be first. Sorry. So 3, 1, 6, 2, and 9, 3. X values we write first, right? X comma y. So the domain is 3, 6, and 9, the set of all first components, and the range is 1, 2, and 3, set of all second components. So domain and range set you can write on your own. That's not very difficult. Okay. 7 sub question 2. Okay. R is equal to x comma y. I'll just write it for you. Such that x comma y belongs to whole numbers and x square plus y square is equal to 25. So x and y they belongs to whole number. So x can take x and y can take 0 also as a value. Okay. Now x square plus y square is equal to 25. So the first x value I am taking as 0. So 0 square plus 5 square. If y is 5, the answer will be 25. Okay. Right. Similarly, if I reverse this, 5 and 0, same thing, the answer will be 25. Right. If I take 3 and 4, 3 square plus 4 square is 25 once again, and 4 and 3. Again, it is 25. So the answer over here is there are 4 ordered pairs. 0, 5, 5, 0, 4, 3, 3, 4. Okay, so this is the relation. In the ordered pairs, I've written, you can write down the domain and range. Domain is 0, 5, 4, 3, and the range is 5, 0, 3, 4. Order is not important, but then that's the domain and range. Okay, let us proceed with question number 8. Question number 8, sub question A. So R has two ordered pairs, x plus 1 comma x plus 5. Okay, such that x is such that x belongs to 0, 1, 2, 3, 4, 5. Fine. So they have given you the descriptive manner. We have to write down the ordered pairs format. So put the value of x as 0 here. So the first ordered pair will be 0 plus 1, 0 plus 5. So 0 plus 1 is 1, 0 plus 5 is 5. Now put the next value as 1. So 1 plus 1 is 2 and 1 plus 5 is 6. Third order pair. Put x as 2. So 2 plus 1 is 3. 2 plus 5 is 7. Then 3 plus 1 is 4. 3 plus 5 is 8. 4 plus 1 is 5. 4 plus 5 is 9. 5 plus 1 is 5 plus 1 is 6. 5 plus 5 is 10. So this is the relation in the roster form. You can write down the domain and range on your end, at your end. Okay. So the domain is 1, 2, 3, 4, 5, 6. The range is 5, 6, 7, 8, 9, and 10. Okay. Second problem, that is B part. The ordered pairs are x comma x cube. X is a prime number less than 10. Okay. So x cube, prime number less than 10, 2, 3, 5, and 7. So 2 cube is 8, 3 cube is 27, 5 cube is 125, 7 cube is 343. Okay. So I can take these values of x because x is a prime value less than 10. Okay. So the roster form 2 comma 8, 3 comma 27, 5 comma 125, 7 comma 343. This is the roster form. From this, you can write down the domain. Domain is 2, 3, 5, and 7. The range is 8, 27, 125, and 343. Okay. Then let us go to the C part of the problem. So in question number C, they have given R, which has A comma B, and A comma B, A and B belongs to integer value, and A minus B is an integer. So just refer this problem. Okay. Now see, there are infinite integers, and any integer minus the other integer will give you an integer only. It will not give you any decimal value. Okay. So domain that is values of x, range values of y. So domain can be any integer, range can be any integer. Any integer minus any integer. Okay. A will be here, B will be here. So A minus B will be an integer itself. So domain can be any integer, range can be any integer, A can be any integer, B can be any integer. Okay. So this was not related to some working. It was related to our understanding of the problem. Question D. R is equal to x comma x plus 5. This is the ordered pair. X belongs to 0, 1, 2, 3, 4, 5. Okay. So x comma x plus 5. So the first value of x is 0. So x plus 5 will be 0 plus 5, which is 5. X value is 1. So 1 plus 5 is 6. X value is 2. 2 plus 5 is 7. Okay. X the next value is 3. 3 plus 5 is 8. X is 4. 4 plus 5 is 9. X is 5. 5 plus 5 is equal to 10. So the ordered pairs are 0, 5, 1, 6, then 2, 7, 3, 8, 4, 9, 5, 10. So the domain is 0, 1, 2, 3, 4, 5. The range is 5, 6, 7, 8, 9, 10. Okay. Let us go to question number 9. Question number 9. So A is -2, -1, 0, 1, and 2. This is A. Okay. R1 is a relation which is written as is less than. So the ordered pairs will be made such that x will be less than y. The first value will be lesser than the second value. So -2, R1. I'm just writing R1. -2 is less than -1. -2 is less than 0. -2 is less than 1. -2 is less than 2. Then -1. -1 is less than 0. -1 is less than 1. -1 is less than 2. Okay. Then 0. 0 is less than 1. 0 is less than 2. And then 1. 1 is less than 2. Now we cannot write 2 because we cannot start with 2 because 2 is not lesser than any other object in the given set. So this is the required relation. Okay. First part of the problem. Second part. A is equal to -2, -1, 0, 1, and 2. The relation R2 is square of. They have given is square of. The meaning is x is the square of y. The first component is the square of the second component. So 0 is the square of 0. 1 is the square of 1. 1 is the square of -1. That's it. 0 is the square of 0. 1 is the square of 1. 1 is also square of -1. Okay. 2 is not square of anything. And negative numbers are also not square of anything. Okay. Yeah. Third one. Additive inverse. Now A is equal to -2, -1, 0, 1, and 2. Okay. R3. It's additive inverse. Okay. So the meaning of additive inverse is the addition of both the components should be 0. Okay. So -2, 2. The total is 0. 2, -2. The total is 0. 0, 0. The total is 0. 1, -1. Total is 0. -1, 1. The total is 0. Okay. X plus y should give you 0. That is the meaning of additive inverse. Now the fourth one is equal to. R4 is equal to. The first number should be equal to the second number. The first component should be equal to the second component. So minus 2 is equal to -2. -1 is equal to -1. 0 equal to 0. 1 equal to 1. 2 equal to 2. So this is the fourth relation. Okay, which is asked. Fine. We will continue with the next problem. Okay. So question number 10. A is equal to 2, 3, 4, 5, 6. Okay. First one, the relation is having ordered pairs x comma y such that x comma y belongs to A cross A. So it's a subset of A cross A and x is equal to y. So the first component x should be equal to the second component. So the relation will be 2 comma 2, 3 comma 3, 4 comma 4, 5 comma 5, 6 comma 6. Okay. Second one, x comma y belongs to A cross A such that x is greater than y. First component should be greater than the second component, and x upon y should not be a whole number. Okay. So x should be greater than y. Is 2 greater than anything? No. Is 3 greater than anything? Yes, 3 is greater than 2. Okay. So 3 comma 2. But then at the same time, 3 upon 2 should not be whole number. So 3 upon 2 is not a whole number. It's 1.5. Okay. Then let us understand for 4. 4 is greater than 2. Yes. But then 4 upon 2 is 2, which is a whole number. So it violates the condition. 4 is greater than 3. Yes. And 4 upon 3 is not a whole number. Right? Then let's start with 5. 5 is greater than 2. Yes. And 5 upon 2 is not a whole number. 5 is greater than 3. Yes. 5 upon 3 is not a whole number. 5 is greater than 4. 5 2, 5 3, 5 4. Okay. Are you understanding? Then 6. 6 is greater than 2. Yes. But then 6 upon 2 is whole number. 6 is greater than 3. Yes. 6 upon 3 is whole number. 6 is greater than 4. Yes. But then 6 upon 4 is not a whole number. 6 5. Yes. 6 is greater than 5. But then 6 upon 5 is not a whole number. Okay. So these are the required ordered pairs. Next one. A is, I'm solving the third one. Just wait. A is 2 3 4 5 6. Okay. The third relation is x comma y belongs to A cross A. X is a divisor of y. Okay. And x is not equal to 1. Fine. Okay. So let us first try to understand the things which are given over here. The first component should be a divisor of the second component. but then both are not supposed to be equal. Now 2 is a divisor of what? 2 is a divisor of 4 and 2 is a divisor of 6. Okay. So 2 comma 4, 2 comma 6. 2 is a divisor of itself also, but then x is not equal to y. Na? So 2 comma 2 is not the answer. 3 is a divisor of 6. Okay. 3 is not the divisor of anything else over here. Now 4 is a divisor of itself, but then 4 comma 4 is not required. But 4, 5, 6 are not, divisors of anything over here. So that completes the third subpart. Okay. The first component should be the divisor of the second component. Let us go to the next question. Question number 11. R is a relation which has x comma y as ordered pairs. X, y, they belong to integers. And x square plus y square is equal to 64. Relatively simple problem. Okay. So x, y, x square plus y square should give you 64. Okay. So if I take x as 0 and y as 8, so 0 square plus 8 square is equal to 64. So the first ordered pair is 0 comma 8, then 8 comma 0, 8 comma 0. This is the second ordered pair, 0 comma minus 8. See, 0 square plus minus 8 square, that will also give you 64. And minus 8 square plus 0 square, this is also giving 64. Okay. So 0 comma minus 8, minus 8 comma 0. The answer is 64. Okay. Any other possibility which will give you 64? I don't think so. Fine. Then 12th problem. Question number 12. N of A is equal to P. 12th sub question 1, sorry. A is a set of even natural numbers less than 8. N of A, even natural numbers less than 8. So 2, 4, 6. This is 3. N of B. N of B is set of prime numbers less than 7. 2, 3, 5. So this is equal to 3. So number of relations from A to B. So number of relations from A to B. So if this is M, if this is N, number of relations from A to B is 2 raised to Mn. 2 raised to 3 into 3, that is 2 raised to 9. Okay. That's the formula. Second sub question. A is a finite set, number of relations on A where A has 3 elements. So N of A is equal to 3. So they're asking number of relations on A. Number of relations on A. On A meaning is on A cross A. So N of A, once again I will write it as 3. So this is M, this is N. So 2 raised to Mn, 2 raised to 3 by 3, that is 2 raised to 9. Okay. And 2 raised to 9 is 5 and 2. You can check it on your own. Okay. Let us go to third sub question. Third sub question. Okay. I'll make the changes here itself. N of A is equal to P. Number of relations on A. On A meaning on A cross A. So this is also P. M into N. 2 raised to P square. Okay, that is the answer. So that is the end of the exercise number 2. Thank you.